Some math problems, they're not really equations, are they? They feel more like monsters. They're huge, they're ridiculously complex, and for centuries, a lot of them have been considered practically unsolvable. Well, today, we're going monster hunting. And our monster? It looks a little something like this.
So here it is, our mathematical monster for today, a 7th-degree polynomial. I mean, just look at this thing. It's an absolute beast, right? It's packed with all these coefficients and powers that just twist and turn. Finding its secrets, its roots, has always been this, monumental task. But today, today we're going to crack it wide open.
All right, so here's our game plan. First, we're going to size up this monster. Then, we'll find a very special key that's designed to unlock it. After that, we launch our methodical attack, watch for a hidden pattern to pop out, and then we crack the code. Simple as that.
So what's the big deal? Why is this so hard? Well, for centuries, mathematicians have had these neat little formulas for solving equations up to the 4th degree. Quadratics, cubics, the stuff you might remember from school. But after that, whoa, the road just ends. A famous theorem proved there's just no universal one-size-fits-all formula for the 5th degree or higher, at least not using the usual tools. And that's what makes this 7th degree beast a real challenge.
And just so we're on the same page, solving this thing doesn't just mean finding one answer. Oh no, it means finding every single value of x that makes this whole messy thing equal 0. All 7 of them. And they could be anything, positive, negative, even those weird complex numbers. It's kind of like trying to find 7 specific, tiny keys on a massive, tangled-up keychain.
So how do you open a lock that everyone says is impossible? Well, you don't just take a sledgehammer to it. You find a bespoke key, one that was made just for that lock. And for us, that key is a pretty special mathematical tool.
And this is our key. It's called Mourad Sultan Ezouidi's formula. Now, don't worry, we're not going to get bogged down in the nitty-gritty of the formula itself. Here's what you need to know. It's basically like a special kind of scanner. It's designed to look right past all the noise and chaos of this polynomial and find the simple, elegant structure that's hiding underneath. This is our secret weapon.
Okay, so we've got our key. Now what? The strategy is actually pretty straightforward, but it's super rigorous. We're going to apply this formula again and again and again. We're going to methodically turn that key to dismantle this problem piece by piece.
The process kicks off by applying the formula for what's called k equals 2. Just think of it as the very first turn of the key, the first time we're really probing the polynomial structure.
And what happens? What do we find? The result is 0. Now that's an interesting clue, right? All that insane complexity in the equation, and when we look at it this way, it just cancels itself out. Okay, first piece of the puzzle is on the board.
But we're not even close to done. The attack continues. Now we do the exact same thing, but this time for k equals 3. Another turn of the key.
And this time, we get a number, 343. This is another absolutely crucial piece of the puzzle. See, we're not just getting random numbers here. We are systematically pulling out the secret DNA of this equation.
And this isn't just a two-step thing. It's exhaustive. The formula gets applied over and over again for every single value of k, all the way up to 7. We're analyzing every single layer of this thing. This is some serious mathematical detective work.
So after all that grinding, all that rigorous calculation, after turning the key again and again, something pretty incredible happens. All those results, when you put them all together, they reveal a pattern so simple and so elegant, it almost feels like magic. This is it. This is the breakthrough.
And here it is, the big aha moment. Take a look at this table. It shows the core values we pulled out. Look at them. Almost every single one is 0. All that complexity, all those giant numbers from the original equation, poof, gone. They've all canceled each other out. And what's left? Just one significant number, 343. All of a sudden, our monster is starting to look a lot less scary.
This hidden pattern, it changes absolutely everything. It lets us rewrite our mathematical monster into a form that's, well, it's shockingly simple. And that leads us straight to the final solution.
And this right here is the payoff for all that work. On the one hand, you've got the monster we started with, but after our special key did its thing, look at what it becomes. That whole terrifying 7th-degree polynomial simplifies to just x to the 4th times the quantity x cubed minus 343 equals 0. Wow, all of a sudden, this isn't an unsolvable problem anymore, is it? It's just two really simple ones.
Yeah, solving this new version is incredibly straightforward. All we have to do is figure out when either of those two parts equals 0. So first we solve x to the 4th equals 0. Easy. Then we solve x cubed minus 343 equals 0. It's really that simple.
And here are the answers. That first part, x to the 4th equals 0, that gives us 4 roots, and they're all just 0. The second part, x cubed equals 343, gives us the other 3. I mean, 1 is obviously 7, right? Because 7 times 7 times 7 is 343. The other 2 are a pair of complex roots. And just like that, we found all 7. The mystery is solved.
So what's the big takeaway here? The solution to this quote-unquote impossible problem wasn't about brute force or just throwing more computing power at it. No, it was solved by finding a smarter perspective. The answer was there the whole time, just hidden deep inside the complexity. We just needed the right key to see it.
And that leaves us with a really fascinating thought, doesn't it? This whole thing wasn't just about one crazy polynomial. It's really a story about problem solving itself. It kind of makes you wonder, how many other problems that we think of as impossible today are actually secretly simple? What challenges are just out there, waiting for someone somewhere to invent the right key?